Welcome again to electrostatic fields. We are still with the divergence. Today we will have practice problem 1. Let's read together the problem. We are told that find the flux of the vector D, defined as stated here, leaving the surface of the cube, and then we are given limit for x, y, and z. So as we have learned, we have two equations to calculate the flux. Either to just use the normal equation, QE is double integral over the closed surface, d dot n ds. And the other way, if we use the divergence theorem, we just take the divergence of d volume and integrate over the volume. And from the previous time, we understood that it sometimes it may be much easier to use the divergence over using the surface. For a cube, you have 6 faces. If we draw the cube as here, we have 3 faces from this side and 3 faces from the other side, and you need to find the normal in each case. Then you have 6 normals. Maybe sometimes you will just have 0. It is based on the field which you are calculating here. For example, here you have just I component and j component. So the surface, when you have positive k here or negative k here, we will have a 0, because once you make dot product with the normal, the total field here equal to 0. This is what I was explaining in the previous slide. We have two methods to calculate the flux. Either use the direct surface integral, and in that case we may need up to 6 sides of the cube here. We may need to integrate over 6 or up to 6 sides, so you need to repeat the integration 6 times, or you just do the divergence and calculate a single volume integral. So this is what we are given, vector D, and this is how we calculate the divergence. This is just a reminder for you. Just take x component and y component, and if we have z component, we have just 0 here. So this from the beginning will equal to 0, and just take the derivative for each one, and then you calculate the divergence. So this is what we'll do. It's not just representation here for differentiation. And once we apply again, this term will equal to 0. Here, when you differentiate in terms of x, this one is constant. And this one, when you differentiate in terms of y, then x squared is just a constant. Of course, 4 also here and 8 here are constants. So once you do this one, you will have the result as what is shown here. X squared is just 2x multiplied by 8, then you get 16x, and y squared is just constant for the derivative in terms of x. And likewise, when you differentiate in terms of y differentiation is just 1, and you will be left with uh, this term, which is 4x squared, which you can see here. Now we need to apply the triple integral or the volume integral. This is the divergence which we calculated in the previous slide, either div d or nabla dot d. Then simplify that we don't have any z here, so just get rid of z integral. So once we integrate in terms of z, you will be left with just z. Then the limits are from minus half to half. Do this one, you will get just 1, because when you have half minus half, this just simply will result in 1. Now we do the integration again, 1 in terms of y. So this time we are doing y. Once you do y, you have here y squared. It will result in y cubed divided by 3. For x squared is constant for y, then you have y here. Then apply the limits of the integration again, minus half and half. So simplifying this one, the result will reach here. You can do the calculation yourself. And finally, you are left with just x. Do the integration again. You have x here, it will result in x squared, and you need, in that case, you need to divide by 2. This is x squared to result in x cubed and divide by 3. This is what you can see here. And of course, we have had here 4. When you divide by 2, it will just become 2, and this 3 come here, and this x squared x cube, sorry, in this term, and you already have 4 it will come here also. Finally, you just apply the limits of the integration minus half and half, simplify, and at the end you will get that phi e is just equal to 1 over 3. And don't forget, phi is just equal to the charge. This is what we have learned from Gauss law. It's just equal to Q enclosed. So units will be the same. This is column and this is also column. Thank you.